Picture this. It's 1950, Los Alamos National Laboratory. A group of brilliant physicists are having lunch, casually chatting about flying saucers and aliens. Then Enrico Fermi, one of the greatest minds of the 20th century, suddenly stops mid-conversation and asks a question that's been haunting scientists ever since. Where is everybody? That simple question became what we now call the Fermi Paradox. And honestly, it's one of the most fascinating mysteries in all of science. Here's the thing. The universe is absolutely massive. We're talking 13.8 billion years old, with an estimated 2 trillion galaxies. Our home galaxy, the Milky Way, alone contains somewhere between 100 to 400 billion stars. That's not a typo. Billions with a B. Now, thanks to NASA's Kepler Space Telescope and other missions, we know that about 1 in 5 stars has a planet in the habitable zone. That sweet spot where temperatures could support liquid water and potentially life as we know it. Do the math. That's tens of billions of potentially habitable planets just in our galaxy. And we're just one galaxy out of trillions. So logically, the universe should be absolutely crawling with life, right? Intelligent civilizations should be everywhere. We should be detecting radio signals, seeing megastructures being built around distant stars, maybe even getting visited by curious aliens wanting to check out this weird blue planet. But we're not seeing any of that. Nothing. Zero. The cosmos is eerily silent. That's the paradox. The math says aliens should be common. The evidence says they're not there. Something doesn't add up. Back in 1961, astronomer Frank Drake tried to tackle this problem mathematically. He came up with what's now called the Drake equation. It's basically a way to estimate how many communicating civilizations might exist in our galaxy right now. Before continuing with the video, don't forget to subscribe and like the video. You can also write your thoughts about the video in the comments. The equation looks like this. You take the rate of star formation, multiply it by the fraction of stars that have planets, then the number of planets that could support life, then the fraction where life actually appears, then where intelligent life develops, then where that intelligence creates detectable technology, and finally multiply by how long these civilizations survive. When Drake first ran the numbers with optimistic estimates, he got thousands of civilizations in our galaxy. Even with pessimistic numbers, you still get a handful. So where are they? Scientists have proposed at least 75 different solutions to this paradox. Some are pretty straightforward. Others get absolutely wild. Let me walk you through the main categories. First up, maybe we really are alone. Life is just incredibly rare. This is called the rare Earth hypothesis. Maybe the conditions that led to life on Earth were a perfect storm of unlikely events. We've got the right kind of star, a stable orbit, a massive moon that stabilizes our rotation, Jupiter acting like a cosmic vacuum cleaner for asteroids, plate tectonics recycling nutrients, a magnetic field protecting us from radiation. Maybe all of this is so rare that we're legitimately the only intelligent life in the entire observable universe. Here's the interesting part, though. A recent survey of over 1,000 scientists in relevant fields found that 87% believe at least basic extraterrestrial life exists somewhere. More than 67% think intelligent aliens are out there, so most scientists don't buy the "we're alone" explanation. Second possibility, the Great Filter. This is a darker theory. Maybe there's some kind of barrier or challenge that prevents civilizations from advancing. The scary question is the filter behind us or ahead of us? If it's behind us, meaning the incredibly difficult step was going from simple chemistry to the first living cell, or from single-celled life to complex organisms, then we're in the clear. We already passed the hard part, but if the Great Filter is ahead of us, that means something wipes out advanced civilizations before they can spread across the galaxy. Nuclear war, climate catastrophe, artificial intelligence gone wrong, pandemics. Maybe every civilization reaches a certain technological level and then self-destructs. That's a pretty sobering thought. A recent 2022 study suggested something called asymptotic burnout. Basically, civilizations grow superlinearly, meaning their energy and resource consumption accelerates faster than their population. Eventually, they hit a crisis point where they either collapse completely or fundamentally change how they operate. If most civilizations collapse, that would explain the silence. Another recent theory involves AI. Michael Garrett has suggested that biological civilizations might universally underestimate how fast artificial intelligence progresses. By the time they realize what's happening, it's too late. The AI either replaces them or the civilization collapses trying to manage it. He argues this could make the average lifespan of technological civilizations less than 200 years. We've only had radio for about 130 years. That's a terrifyingly small window. Then there's the distance problem. Maybe aliens exist, but space is just too vast. The nearest star to us, Proxima Centauri, is about 4.2 light-years away. At current rocket speeds, it would take us over 30,000 years to get there. And that's our closest neighbor. The Milky Way is 100,000 light-years across. Even if civilizations are out there, the distances might be so enormous that we're all effectively isolated from each other. Astrophysicist Paul Sutter puts it well. He says maybe Fermi was right that we're not alone, but he missed something important. The universe is so gigantic that we're effectively alone anyway. Every star we see in the sky might be unclaimed territory, just waiting to be explored. The bad news is we'll probably never meet another intelligent species. The good news is the galaxy is ours for the taking. Now let's get into some of the weirder theories. The zoo hypothesis suggests that aliens know we're here but are deliberately leaving us alone, like animals in a zoo or a nature preserve. They're watching us, studying us, but have some kind of prime directive not to interfere until we reach a certain level of development. Even stranger is the dark forest theory, popularized by Chinese science fiction author Liu Cixin. This suggests that the universe is like a dark forest full of armed hunters. Every civilization is hiding because revealing yourself is dangerous. If you broadcast your location, you risk being destroyed by a more advanced civilization. So everyone stays silent, listening but never transmitting. It's basically cosmic game theory where the only winning move is to hide. The planetarium hypothesis takes things even further. What if advanced aliens are creating an illusion that makes space appear empty to us? Like we're living in a cosmic Truman Show, and they're projecting a false reality to keep us in the dark about their existence. And then there's the simulation hypothesis angle. Some theorists suggest that sufficiently advanced civilizations might abandon the physical universe entirely. Why explore dangerous space when you can create perfect virtual realities? Maybe every advanced civilization eventually uploads itself into digital paradise and loses interest in the physical cosmos. Here's something that blows my mind. Astronomer Avi Loeb suggests that virtual reality technology might be the answer. Think about it. Individuals in extraterrestrial civilizations might prefer spending time in virtual worlds with completely different physical laws rather than dealing with the harsh realities of space travel and colonization. Why spend centuries on a generation ship when you can experience anything you want in VR? There's also the possibility that we're just not looking in the right way. Maybe aliens communicate using technologies we haven't discovered yet, or maybe they're using methods we can't detect. We've only been seriously searching for about 60 years, and we've barely scratched the surface. As astronomer Jill Tarter put it, trying to conclude whether aliens exist based on our current searches is like dipping a glass into the ocean and concluding there are no fish because you didn't catch any. The timing issue is huge too. The universe is 13.8 billion years old. Our solar system is 4.5 billion years old. Humans have only had technology for about 10,000 years, and we've only been broadcasting radio signals for roughly 130 years. That's nothing on cosmic timescales. Think about it this way. If there were 1,000 civilizations in our galaxy, and each one lasted only 10,000 years like we have so far, the odds of two civilizations existing at the exact same time are incredibly small. Most of them would already be extinct, and others won't evolve until long after we're gone. We could be living in the gap between fallen empires and future civilizations. Recent research has actually given us a new perspective on this. Adam Frank and Woodruff Sullivan revised the Drake equation to ask a different question. Not how many civilizations exist now, but how many have ever existed throughout cosmic history. When they ran those numbers, even with pessimistic estimates, they found that we're almost certainly not the first technological civilization the universe has produced. We're probably not alone in the grand scheme of things, just alone in time. So what's the answer? Honestly, we don't know. And that's what makes this so fascinating. We're trying to solve a mystery with extremely limited data. We've got a sample size of exactly one intelligent technological civilization, ourselves. That's not much to work with. What we do know is this: the search continues. Projects like SETI are constantly scanning the skies for signals. New telescopes are finding more exoplanets every year. The James Webb Space Telescope is analyzing the atmospheres of distant worlds, looking for biosignatures. We're sending probes to places in our own solar system that might harbor life, like Jupiter's moon Europa or Saturn's moon. Enceladus. Maybe tomorrow we'll detect a signal. Maybe we'll find microbial life on Mars or in the oceans of Europa. Maybe we'll discover that we're surrounded by civilizations that have been quietly observing us all along. Or maybe we'll eventually conclude that we really are alone, or at least alone enough that it doesn't matter. Either answer is profound. If we're alone, that makes humanity incredibly precious. We might be the universe's only way of understanding itself. If we're not alone, that changes everything we know about our place in the cosmos. The Fermi Paradox isn't just about aliens. It's about us. It's about understanding the likelihood of intelligence, the fragility of civilizations, and the fate that might await us. Every solution to the paradox tells us something about what the future might hold for humanity. So, where is everybody? The truth is, we don't know, but keep looking up. Because the answer to that question, whatever it turns out to be, will be one of the most important discoveries in human history.